Morning. Let's see the topic of queue implementation using single linked list. So we already know the queue concept. It is a linear data structure with list of elements with which a new element can be inserted only from the rear end and an element can be deleted from the front end. The same concept, now we will see the implementation using single linked list. So we know that single linked list, by employing this single linked list concept for queue, we can define this queue as linear data structure with list of nodes wherein a new node can be inserted into the queue only from the rear end and a node can be deleted from the queue from the front end. Like that we can view. So if you consider like a queue with 3 elements A, B, C, and we have this will act as our front end, this will act as our rear end. If you want to insert a new node for this to the rear end, like for this last node, you have to link your new node. So maybe C, whose pointer again you have to make it as null. And now if you want to delete a node, delete an element, it is possible through the front pointer. So this is the node you can delete, and after deleting this you have to make this particular node referred with your front pointer. Like this you have to perform insertion deletion operations on the queue with single linked list. But now let us see writing the code statements for this, but for the operations of queue using single linked list. So we will get the operations: inserting a new node into the queue. So the new node, it can be, we know that we have to assign memory for that, and we have to, it is your let's write this for new node creation. It will be your new struct node star using your malloc function, size of struct node, and news data you can keep some 100, and news link can be made as null. Like this, every time we are creating a new node, we are creating the memory for a new node. And for this, in order to develop the module for this insert operation for the queue with single linked list, if you consider the pointers first, initially both the pointers front and rear, we have to take them as null. So for this we can write the statement struct node star front star rear equal to null. These two pointers we have to make null, and this is new is for representing the new node to be added. Now before insertion, before doing the insertion, first of all we have to check whether any nodes are there in the queue or not. For that we can check for this front pointer, because this front pointer is acting as the start pointer for a single linked list. In the earlier programs with single linked list implementation for stack and single linked list operations, usually to check whether the list is empty or not, we verified the condition start equal to null. So in the similar fashion here, instead start we directly using the front pointer. So we have to check for the front pointer. If front equal to null, we can say that your list is empty, there are no nodes. So if front is empty, there are no nodes, and your new node will become the first node in the queue. So how to make this new as your first node? Like you take this is your new node with 100 data. Now you have got your front pointer, rear pointer, both are null. After this node is inserted into the queue, your front has to refer this particular node and rear also has to refer this particular node, and this node's address part should have null. So for that we can write front equal to rear equal to this new, and this new's link is null. This is the first case. Else, if it is not empty, if it is already having one node like this, or two nodes we have, it is the case, this above case we can consider already some nodes are there. So if already nodes are there, this front is referring this first node and rear is referring the last node. So now to insert a new node here, to the rear directly you can connect to the new node. This is your rear node. To rear node you can directly connect your new node. For that, how can we write instructions? It is your rear link equal to your new node, and news link should be null, and after connecting this to this new node, you have to make this new node as your rear end. For that, this new pointer has to be assigned to your rear pointer. But before that, you have to make one more step. In order to perform like deletion operations on the singly linked list, we need to have a previous pointer for the rear node. Sorry, previous pointer is not required. Simply we can do it like rear equal to new. With this statement, we are storing the address of new node into rear pointer. So our last node now it is made as rear. So using these instructions, you can perform insertion on the queue with the implementation of singly linked list. Okay. Now let us see the deletion. Implementation of deletion. Here if you see, there are cases if there is only one node in the queue, like only one node you have and that node is referred with front and rear. So how do you know that there is only one node in the list? Using the condition front equal to rear, you can say that only one node. And empty list, you have to check for the condition for empty list. If front equal to null, it is empty list. Otherwise if there are some number of nodes. If there are some number of nodes, in order to delete a node, you have to simply move from the current friend pointer to the next node. How it is possible? Using the statement friend equal to, using the statement friend equal to friend link. So you can, like later you have to free that friend node. So these are the three cases we'll get. First, if you see the first this empty list case, if friend equal to null, your queue is empty, it shows the condition of underflow, there is no possibility to delete, so you can go for printing a message that is underflow. In the else case, there are some nodes, either the possibility one node or multiple nodes. But here one thing we have to do is that whatever node you are deleting, that node's data you have to return it or you have to display it, and you have to make the memory whatever is assigned with the node to be deleted, you have to free it. For that purpose, before we make this traversing, before we make this move from the current friend to the next node, we have to save the current friend node in the temporary pointer. For that, let's take a temporary pointer, struct node, some temporary pointer. So into the temporary pointer, we'll take the friend pointer, address of the first node. Then let's check if friend is equal to rare, which is indicating there is only one node in the list. In that case, we have to make that node also gets deleted. If only one node and that node is deleted, what will happen to the friend and rare pointers? Both pointers will become null. So we can write friend equal to rare equal to null. If it is the else case, there are multiple nodes in the list, then this is the case, this we want to delete, so it is friend equal to friend link we have to write. So friend equal to friend link, the current friend, like we want to delete this, so the current friend is updated to the next node, and this friend node we already have in the temp pointer. So you have to make now this temp pointer node memory to be freed. For that, this temp nodes link, let us make it null. This node is linked with this particular list, so first let us break this link by the statement temp link equal to null, then free the memory which is allocated for the particular temporary node. So we have freed it with this particular instruction. So with this we have completed all the three cases for deleting a node from the queue, which is implemented using singly linked list. Okay, thank you.